Hello everyone, welcome to the tutorial on Basics of Linear Algebra. In today's tutorial, we will look at what is a linear equation, what is a system of linear equation, and what is a solution of the system, and how do we obtain the solution set. Firstly, what is a linear equation? A linear equation are the equations having variables of degree 1. When I say degree 1, or I can say power equal to 1. So say a linear equation is having the variables x1, x2 up till xn, then the linear equation can be written as a1 x1 plus a2 x2 plus an xn equal to b, where a and b are the coefficients which could be either real or complex. Now let us look at some of the examples as to how to identify whether it is a linear equation or not. So let me consider the example 1. So I have an equation 4x1 minus 5x2 plus 2 is equal to x1. So the first task would be to rearrange this particular equation. So on rearranging, I have this as 3x1 minus 5x2 is equal to minus 2. So if you look at the variables x1 and x2, x1 is having a power 1 and x2 is also having a power 1. So this can be considered as a linear equation. Let me go to the second example. In the second example, let me consider x2 equal to 2 times square root of 6 minus x1 plus x3. So let me rearrange this. This can be written as 2x1 plus x2 minus x3 equal to 2 root 6. In this case also, the variable x1 is having a degree 1, x2 is having a degree 1, and x3 is also having a degree 1. So this is also a linear equation. Third example, 4x1 minus 5x2 equals x1 x. So if you look at this particular equation, here this is having a degree 1, x2 is having a degree 1. In this particular case, x1 is having a degree 1 and x2 is having a degree 1, and these two together, x1 multiplied with x2, will have a power equal to 2. So this particular equation has a variable which has a degree greater than 1 and not equal to 1. Hence, it is not a linear equation. Let me consider another example. In this case, x2 equal to 2 root x1 minus 6. So for a better understanding, let me rewrite this equation. This can be written as 2 times x1 to the power half minus x2 equals 6. So if you look at the variable x1, this is having a power of half, x2 is having a power of 1. Since the power is not equal to 1 in all the variables, I can consider this as not a linear equation. So to summarize, linear equations are the equations which are having variables of degree 1 only, or I can say power equal to 1 only. Next, system of linear equations. System of linear equation can also be simply called as a linear system. So system of linear equations or a linear system is basically a collection of one or more linear equations. So when I say collection of one or more linear equations, they should involve the same variables x1, x2 and xn. When I say same variables, what I mean is that you cannot have one equation consisting of variable x and another equation consisting of variable y. So both, say if you consider two equations, both the equations should have the same variables x, or they should have same variables y. The number of variables can be more or less, but you should have the same variables, either completely x or completely y. So let me explain this with an example. I have a system of linear equation phi x minus 2y equal to 7 minus 2x plus y equal to 3. So this is my first equation, this is my second equation. So in this particular case, if you observe, I have variable x and I have variable y in the first equation, and I have x and y in the second equation. So both these equations are having similar type of variables, so you can solve them. So let us solve this system of equations. So to solve this, if you observe the variable x in both the cases, you have 5 here, here you have 2. So I can solve this as the equation 1 can be multiplied with 2. So this becomes 10x minus 4y equals 14. The equation 2 can be multiplied with 5, and this becomes minus 10x plus 5y equals 15. So let us add this, and you can observe that these two get cancelled, and I have this as y equals 29. So I have obtained the variable y. Now let me substitute this back in one of the equations. So I can substitute this as phi x minus 2y equal to 7. So phi x minus 2 times 29 equal to 7, or x is equal to 13. So we have obtained the value of x equal to 13 and y is equal to 29, which is a solution to the system of linear equations phi x minus 2y equals 7 and minus 2x plus y equal to 3. Now I told you that we should have same variables, right? So when I meant same variables, you should have same variables in both the equations. You cannot have, for example, phi x1 minus 2x2 equals 7 and say minus 2y1 plus y2 equal to 3. No. So if you get a linear equation like this, this does not become a system of linear equations because it is not a collection of the same set of variables. So if that is understood, let us move on to the next topic, that is a solution set. So here in this particular case, what we did was we tried to solve this system of linear equations in order to obtain the variables x and y. So a solution of the system of linear equations is a set of values. It is a set of values for the variables which make the solution, which makes all the equations true. So this is nothing but corresponding to the solution set. So solution set is a set of values for the variables which we obtain after solving, which makes the equations true. Now coming to the solution set. So solution set is a set of all possible solutions of the linear system. So if you have two linear systems, they could be called as equivalent if they have the same solution set. Now let us see how do we find the solution of a set of system of two linear equations with two variables. Let me consider the example x1 minus 2x2 equals minus 1 minus x1 plus 3x2 equal to 3. Now if you look at this particular equation, we can directly add these two equations and we get this as x2 equals 2, and on substituting we have x1 equals 3, right? So if I have to draw this two lines corresponding to x1 and x2 in the coordinates, I have the common point 3, 2 corresponding to x1 and x2. So finding the solution of a set of a system of two linear equations in two variables is very easy because it just amounts to finding the intersection of the two lines. So one linear equation in this case corresponds to one straight line. The second linear equation corresponds to a second straight line. So the point where these two intersect would be the solution of the system of two linear equations in two variables. So if there is only one single point of intersection, that means the equations have exactly one solution. But it is not necessary that if you have two linear equations in two variables that they should always intersect. There might be some equations which cannot be solved at all. In such cases, these two lines L1 and L2 will appear parallel to each other with no point of intersection. In such cases, we say that there is no solution that exists in order to solve these two equations. For example, let me consider x1 minus 2x2 equal to minus 1 and minus x1 plus 2x2 equal to 3. Now if you look at these two equations, when I add these two equations, even this becomes 0, this also becomes 0, and this is equal to 2. So there is no such solution. We are not able to obtain the variables x1 and x2, and in such cases, if we were to draw x1, x2, these two lines would appear parallel to each other, which indicate that there is no point of intersection and there is no solution. Now, let me consider the third case. In the third case, I have the equations as x1 minus 2x2 equal to minus 1 and minus x1 plus 2x2 equal to 1. Now, when I add these two, I get the result as 0, right? So, this is 0, this is 0 equal to 0. So all the variables will be equal to 0. So if you see, these two lines basically are overlapped. They are overlapped on each other. So you have L1 and L2 which basically coincide, and that indicates that there are infinitely many solutions. So given a set of linear equations, we can have exactly one solution, we can have no solutions, or we can have infinitely many solutions. And this is not restricted to a system of two linear equations in two variables, but if it is a case of a system of two linear equations in two variables, then we can find the intersection of the lines and we can easily tell. But otherwise, we need to solve and we need to identify whether there are pivot variables, whether we can find out the free variables, and then check. Thank you.